So this is, well, we're going to cover Chapter 8 today. And so this week we're going to cover Chapter 8, and then next week will be Chapter 9, as you would expect. Okay, and then there will be a quiz, and then we'll I'll touch on a few last topics and of new stuff. There's these Chapter 8 and 9. There's quite a bit to cover, and then we'll have a review for the final exam, and then the final exam. So you got about, including today, you have 3 weeks of new content, and then a week of review, and then you'll have the final. Okay. There's a practice final exam posted online, and I think that will be helpful. But we haven't really learned any of the stuff that's on the practice final yet, just barely. So. Yeah, confidence intervals, that will be there, but beyond that, not too much else. Okay. So, today we're going to learn Chapter 8, which is all on hypothesis tests. All right, so before I start writing stuff up, let's talk a little bit about how a hypothesis test works. Okay. So a hypothesis test is like having court for statistics. Okay, it's like Judge Judy, but it's like statistics court, or the people's court, the stats court. And so when you go to court, the way we have it set up is you've got the defendant and then the prosecution, and the prosecution is trying to prove that the defendant is guilty. Right? So they present all this evidence and they say, this is what happened, and we believe the defendant to be guilty. Right? All right, so with hypothesis tests, we don't have a defendant, but we have something called a null hypothesis and an alternative hypothesis. And we're trying to prove that the alternative hypothesis is true. We present evidence to show that the alternative hypothesis is true, or we don't have enough evidence to do that, and we default to the null hypothesis. Okay, so if you think about court, the prosecution tries to present evidence to say the defendant is guilty, but if they don't have enough evidence, then you default, or you say we don't have enough evidence to convict the defendant, right? It doesn't prove that the defendant is innocent, right, but it just says you don't have enough evidence to make a case, or you don't have enough evidence to bring about conviction. Okay? And same thing with hypothesis tests. We've got an alternative hypothesis, and we present evidence in the form of data, either to support it, or we say we don't have enough evidence to support this, and we default to the null, which would be something else. And we use our understanding of probability and the normal distribution and all of that in our case. Okay. So let's just say, and maybe I used this example already. I don't know. Let's say I go to Las Vegas and somebody accuses me, and I play roulette, right? And you're supposed to, and let's say I bet on the color red. Okay. And the way the table is set up, I should win a little bit less than half of the time. Okay, so every time I play, I've got a little bit less than 1/2 probability of winning. And so let's say I play 100 games of roulette. I don't know, I got tons of money to burn, and so I play 100 games of roulette, and according to the rules of probability, I should win a little bit less than half. So maybe I should be winning maybe 47 out of the 100 games I play, or 48 out of the 100 games I play, something around there. Okay. Let's say I win 52 games, so I win a little bit more than half. Okay. And then there's a casino manager or pit boss. It's his first day on the job, and he says, "You won 52 games. That's too much. I think you're cheating." Okay. Would you agree with the pit boss? No. Why not?
Because whenever you get lucky.
Huh?
Maybe you get lucky.
Yeah, maybe I got lucky, right? Maybe this is just my lucky day, and I won a little bit more than what the casino guy thinks I should, right? So according to probability, I should win maybe 47, 48 times. I've won a little bit more than that, 52 times. That seems reasonable. Okay, seems reasonable within what could happen just by random chance of playing roulette. Okay, are we in agreement there? Okay. So if that was the scenario, casino guy says you're cheating, we'd say no, you don't really have a case. Okay. Let's say I come back to Las Vegas, I play, and this is another day, all right? I play another 100 games of roulette, and this time I've won 70 games. 70 games of roulette out of the 100. And the casino guy says, I think you're cheating. You're winning too much. Would you agree with him, or would you say, nah, you just got really, really lucky?
I'd agree. Too much. Lucky.
Okay, so some would say, maybe I'm just really lucky, and some would say, okay, that's a little bit too much. Winning 70 out of 100 games, a little bit too much. Maybe you are cheating, okay? And that's kind of how hypothesis tests work, okay? And we can use our knowledge of probability, okay? Just like this quiz, okay? We can use our knowledge of probability in the normal distribution to actually find out if it's possible that I'm lucky, or if it seems that I'm cheating. Okay. So let's try this out here. Okay. So this is our casino example. So I play roulette. I play 100 games. I win 70 games. Okay. According to the rules, the probability of winning betting red. So somebody just tell me what 18 divided by. I forgot my calculator.
Okay.
18. I've already said. I know. It's because I figured out. Okay.
4.473.
Okay, so let's say 0.474. So,
Yeah.
so it's a little bit less than 50%. So that's what I should be winning. Okay, and I win 170 games. Does this mean I'm cheating? Okay, so this is there's two things that could be going on here. All right, one is I'm not cheating, and the other is I am cheating. Okay, so we set up something, and we'll get into the details of all of this. Okay, but I'm going to call this the null, and we have an alternative. So we're trying to prove one, and if we don't have evidence for this, we default to the null. Okay, so if you don't have enough evidence to support the alternative, you just default to the null. So it's just like if you don't have enough evidence to convict the defendant, you default to acquitting the defendant. Okay, that's how we have our justice system set up. Okay, other places in the world, you know, it's not set up that way. But in America, you have to, the onus of proof falls on the prosecution. Okay, so in this case, it's Miles is cheating. Roulette. And the alternative is it's not cheating. Okay. If I were not cheating, okay, so let's say so the pit boss comes up to me and says, "You've won 70 games out of 100. That's too many games, all right? I think you're cheating." Okay. So I'm gonna say, "Oh, what? What? I don't know what you're talking about, right? I'm not cheating. I'm not cheating." Okay. So what he's gonna do is he's gonna say, "Okay, you know what? For argument's sake, let's say you were not cheating. Let's say you were not cheating. Then let's tell me what is the probability that you would win 70 games out of 100 based on sheer luck." Does that make sense?
Mm-hmm.
We're going to say, okay, you're saying you are just lucky. Let's find the probability that you would win 70 games out of 100 based just on sheer luck. Okay? So let's think about this for a moment. If we do the calculations and we figure out the probability, for me, for my defense, do I want that probability of getting 70 out of 100 wins to be high or low? I want that to be high, right? I want it to be like, look, there's a good chance of getting 70 wins out of 100, okay? All right? But if it's like only 1 in 10,000 people will win 70 games out of 100 based on sheer luck, then that is pretty strong evidence that I'm cheating, right? Does that reasoning make sense?
Yes.
Okay. And this is what we're going to do here. So we're going to say, okay, for argument's sake, let's say you are not cheating. And let's find that someone wins 70 games out of 100. Okay, and I'm going to write one more. I should actually write 70. I can put 4 more over here, sorry. Out of 100 based just on pure luck. Pure luck or random chance alone. Okay, so that's what we're going to do. Let's say you're not cheating, okay? Okay, then let's find the probability that someone wins 70 games or more out of 100 based on pure luck or just random chance alone. And we're going to figure out this probability. Okay, can we figure this probability out? Do we know how?
Divided by 100.
Huh? We know how to do this? We do, okay? And we did something like this on the quiz.
70 over 100?
Huh?
70 over 100, isn't it?
Yeah, so, well, okay, so I'm going to rewrite this question in the form that you might have seen on the quiz, okay? And so you can see how everything builds up on each other. So if you feel like you totally bombed this quiz and did terrible, then please make sure you can do the stuff on the quiz, because what we're doing this week just builds up on that, and if that was terrible, then this is not going to be any better, okay? So, alright, so I'm going to rewrite this question into a form that is kind of familiar from the quiz, okay? It's going to say the probability that, or we'll say When someone plays roulette, the probability he will win, he wins by betting on red, 0.474. A person plays 100 games. What is the probability he wins 70% of 70 of his games or more? All right, so this looks at least in a similar form as what we saw in the quiz, right? Okay, and this is the same question here, but it's kind of written in a form that we are familiar with. So, why don't I give you guys a few minutes and you figure out the answer to this problem. Score 4.5?
Yeah.
Okay.
Yeah.
Alright, and then the probability okay, is going to be different to answer.
We have to look here, right?
Yeah, you're going to have to look there, but it's not a, well.
We don't have 4.
You don't have 4, yeah.
Yeah.
You're right.
The quiz is right, 4.52, you mark off.
That's fine, that's close enough. Okay.
So then, no.
Alright, so let's talk about this, okay? Alright, so we say, alright, for argument's sake, let's say you weren't cheating, alright? Okay? If you weren't cheating, then the probability that you win any one game in roulette is 0.474. And now you're playing 100 random games of roulette, right? Every outcome is random. So what's the probability that the proportion of wins that you get is 70% or more? Okay. So we say, all right, let's do our work. So according to this, you would be centered at 0.474. Anytime you play games, we're expecting you win about that much. And you're telling me you won 70%. So what's our standard error? Our standard error is going to be the square root of 0.474 times 1 minus 0.474 over 100. And then I don't know what that was.
0.0499.
0.0499?
Yes.
Okay, great. Okay, and then what I observed, okay, so my z-score here, I got 0.70 minus 0.474 divided by 0.0499, whatever, okay? I get a z-score of 4.53. So the proportion of wins that I observed, 70% wins, that's 4.5 standard deviations away from the mean. Does that seem like a lot?
Yeah.
That's a lot, right? We say 2 standard deviations quite a bit, 3 standard deviations is
So-
pretty extreme. We're 4.5, okay? There's actually, if you look in the table, in the little right-hand corner, you can see the proportion that's at 4.5 standard deviations, okay? And the proportion over here is going to be 0.999. How many nines is that? 5 nines
6, 6.
followed by 6, 6, okay? So in other words, I've got, alright, so I've got, that's my probability.
This
Okay?
is not yours, right?
This is the probability. This tiny number here.
Yeah.
So 3 in 1, 2, 3, 4, 5, 6. So 3 in a million, okay? About 3 in a million. Yeah, this is,
No,
the
the
z-score is
probability.
4.53, and the probability of being 4.5 standard deviations or more is about 3 in a million. Okay.
So it's like it's
So this is I've got this at this point. This is really my only defense. Okay.
Right.
He's got his baseball bat. He's gonna break my kneecaps, right? Or just say, don't come to my casino again. And this is my defense, right? Because if I'm saying I'm not cheating, right? I'm saying, oh, no, I didn't cheat. I just got really, 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 really lucky. Okay. All right. Okay. So it's possible that I'm really, really lucky. Okay. It's possible that I won 70 games out of 100 based on pure luck alone. But what is that probability? The probability that I won 70 games out of 100 based on pure luck alone is 3 in a million.
Yeah.
3 in a million. So, as a casino boss, do you believe me when I say I was one of those lucky 3 in a million people who won 70 games out of 100? Or do you say, maybe you were lucky, but I have a feeling you are cheating? Okay? You're going to say, I don't think you were one of the 3 in a million. Okay? It's much more likely that you were cheating. Yes? Oh, I did. When I look up, technically I can't look up 4.53, but if I look at 4.5, I get 0.9999966, and 1 minus that is
But then-
0.00034.
I want to see something. So then, if that mentality, is always in casinos, then whoever does win, they won't believe the person who wins, because the people who win are very rare. You know what I mean?
So for one given game, sure, a bunch of people can win, and that's
Okay,
not that
based on
weird.
the expectations of that
Yeah,
game.
but if you win 70 games out of 100, we're not going to chalk it up to just being lucky.
Right.
All right. That's what's going on. So if you just play one game, if you play 5 games and you win 5 games out of 5, yeah, maybe you were just really lucky. Okay, that's possible. But to win 70 games out of 100, it's probably not just sheer luck that's getting you this. Okay. I want to make sure this line of reasoning
Yeah.
works. Okay. On the other hand, okay, so let's say, so I get kicked out of that casino, all right? And then I'm like, oh, okay, I confess, I was cheating, all right? Alright, so now they make a sequel to the movie. It's 20 years later, I'm a hardened man now. Alright?
So funny.
And, but I get the itch to go back to Vegas. And I say, oh, my cheating days are behind me. Okay? And so, so I go and I play, I decide to play roulette again. Okay? This time, I'm like, I'm just going to play 10 games and I'm going to bet big on these 10 games. Okay? So, so this time, I play 10 games. Or actually, 10 is not enough, right? 10 will not be enough for our, to meet the large sample condition. So I got to play 25 games. Okay. So I play, 25 is not going to give me a nice number. 30 games. Okay, so I play 30 games. Okay, and I win 21 games. So my proportion of winning is still 70%. Okay, so I still win. Win rate is still 70%. And I go back to, you know, a new casino, but the old pit boss is there again. Says, I remember you. I caught you 20 years ago. All right. Okay. And then I play 30 games. And I win 21, and he says, "You won 70% of your games. I know you're cheating again." Okay? I say, "No, I swear, those days are gone." Okay? I swear, I'm not cheating. Okay? Well, all right. So this time, he says, "Well, let's do the math again." All right? I took Mr. Chen's statistics class, so I can figure this out. So now, okay, so we redo the thing, okay?
Do the steps again?
We're going to do the same steps, except this time, instead of playing 100 games, I've only played 30.
Yeah.
A person plays 30 games. What is the probability he wins 70% of games or more? Okay, so now this is what we've got. I won 21 out of the 30 games. 70% of games.
Okay, so same data.
So, no, it's new data, but it's 30 games now. 30 games.
It's
30 takes the place of 100, basically.
30 takes the place of 100.
right.
So our picture looks very similar. I've got 0.474 here, and I put 70 over here. I hope this works. Maybe 30 is still too big. 30 might still be too big. Okay. So my standard error is 0.474 times 1 minus 0.474 over 30.
We would still be calling it standard deviation, right?
Yeah. Standard deviation. Technically, they're a little bit different, but close enough. Okay. What is this number here?
0083 091
.09? 912?
Yeah.
Okay, so, this still might be too much.
I think we get your point though, that
Huh?
I think we get your point that if the numbers are different, that the
Okay, well, I just want to see. Okay, what's my z-score now?
2.49.
It's still too big. Okay, I'm still gonna get busted here. Huh?
49.
2.49? 2.49. I'm still gonna get busted. We're still gonna.
About 7 out of 10.
But it's not so.
Yeah, 7 out of 10 would be nice, but I would not meet my large sample conditions. Okay. Shucks. And actually, at 21, I'm still not. 30 games, I'm still technically not meeting my large sample condition. Okay. Well, anyway, all right. Let's try. Let me just make up different numbers. Let's just make up different numbers here. Okay. So here I got 2.49, but let's say. Sorry. I have to work something that's not so extreme. Alright, so let's say I only win 60% of my games. Okay. So this part is still all the same. 0.474 times 1 minus 0.474 over 30. I still have, what did you guys say, 0.0912?
Yeah.
Okay, and then my z-score now is going to be 0.60 minus 0.474 divided by 0.0912, and this is 2? No. 1.5?
1.38.
Huh?
1.38.
1.38, great. Okay, this is a much better number. Okay.
So now I believe you.
Yeah, so what is this? 1.38?
Yeah.
Okay, so what do I get when I look at 1.38 in the z-table? 9162. And so that means over here I have 0.0838. Okay? Okay, so now it says, I think you're cheating again, alright? I say, no, I swear I'm not cheating, okay? Now, so we do the math, and what this says is if someone was not cheating, someone's playing just by the rules, playing it fair, there is a 8%, about 8.4% chance that someone will win 60% of the games out of 30 games. Okay, so someone was going to win this 60% out of 30 games. Does that seem reasonable? Okay. So, it doesn't happen often, huh?
But you also have to know, like, if you cheated previously, then those.
Oh, okay. So, all right. So.
Like isolated.
Yeah. Okay. Let's just. All right. Now, just a random person, or I don't know. Okay, whatever. So we'll say these are truly. We'll just give you the benefit of the doubt and say that this person is truly playing fair. If someone is truly playing fair, what's the probability that they will win 60% of their games, or something more than that, if they play 30 games? The probability of winning 60% of their games out of 30 is about 8%. Okay? So if something happens just by random chance 8% of the time, would we, and it happened, would we say that that means that person's cheating, or it could just be part of the 8% that happens?
It can be part of the 8% that happens.
Yeah, okay, so it happens to 8% of people who play roulette 30 times, okay? It happens to 8% of the people. And so we would consider those 8% to be lucky, and it would not, just because somebody won 60% of their games out of 30, we would not then go on and immediately say this person is cheating. Alright? Because the probability of it happening just by random chance is too big where we can't just ignore it. Okay? Because it can happen just by random chance. That's what the probability in the statistics, the math part comes in to show that it can happen just by random chance. It happens by random chance about 8% of the time. So we can't just say this person's cheating. Yeah.
If it happens 8% of the time, the same as not cheating. 8% is enough.
Yeah. Well, so we have to make a judgment.
Like out of 100, 8% is still.
Yeah, I mean it doesn't happen often, but
the probability is
It's
there.
a lot more believable than the 3 million.
yeah, 8%, 8 out of 100 is a lot more. If someone's using this as a
Plausible.
defense, right? If someone's using this as a defense, 8% out of 100 is a lot more believable than someone saying, no, I was just one of the lucky 3 in a million. Okay.
Yeah.
If someone says, I swear, I'm just one of the lucky 8 out of 100, you're like, okay, I don't quite trust you, but you're right, I can't, this is not enough for me to break your legs, okay? Does that make sense? And it doesn't prove that I'm innocent, okay? I could be cheating, but I wisened up and I've only played 30 games, and it's not enough for you to say with you know, quite a bit of confidence that you're cheating, okay?
I think that's a super high probability. It's like 1 out of every 12 people that watch.
Yeah, so 1 out of every 12
Yeah.
people, it's gonna happen to 1 out of every 12. So
Yeah.
about 8%, it happens, and so it's not enough to say you're cheating, okay? It's just sometimes it happens, and at this point, I can't say someone is cheating. It's just, or the casino guy can't say I'm cheating. It just means, all right, we don't have enough proof. Okay? Yes.
Well, is there like a certain range, like?
Yeah. So we'll talk about that. Okay? We'll talk about that. And yeah, we actually draw kind of a line, and we say if the probability ends up being higher than a certain number, we're gonna say it's not enough to prove that you're cheating, and if it ends up lower than a certain number, we're gonna say we're gonna suspect you're cheating or something. Okay. All right. So this is the idea. So let me just write this. So about 8.38% of people will win 60% or more of 30 roulette games. Based purely on luck or chance. Purely on random chance. So we do not have enough evidence to say someone is cheating.
To debunk it, basically.
Yeah.
So can I just ask you, you were saying
Yes.
before that if there's not enough evidence, you default to null.
The null hypothesis, yeah.
Yeah.
So because there's not enough evidence, we just default to he's not cheating. Okay. It doesn't.
Right.
It,
No. Okay.
Yeah. It doesn't prove that I'm not cheating. It just at this point it's just we don't have enough evidence to say that I'm cheating.
Right.
And that's the null when you're defaulting to it?
Yeah, you either have enough evidence to reject the null and support the alternative, or you don't. Okay, and so we'll talk about all of the details, but I just kind of wanted to use this example to kind of give you an idea of the kind of the way of thinking for these hypothesis tests. Okay. Yes.
On the previous example, you did say that there is enough evidence, so therefore you're cheating, right?
Yes. Yes.
Yeah.
Okay. So this is kind of how the hypothesis test procedure works, okay? And we'll talk about each step along the way. But yeah, the big picture is we set up some hypotheses, okay? We've got something to default to, that's the null, and we have something that we're trying to prove using our evidence. And then we go through the probability calculations using our understanding of central limit theorem and this normal distribution stuff. Okay? And the probability that we're calculating is if the null hypothesis were true, or if someone is not cheating. Okay, so in this case it was someone's not cheating, but whatever the null hypothesis states, we're going to say, let's assume that's true. If that's true, what's the probability of observing our data or something more extreme? And if the probability of observing our data is high, then we don't have enough evidence to reject that null hypothesis. If the probability of observing our data is really low, then we reject the null hypothesis. Okay? So relating that back to here, our null hypothesis was Miles is not cheating. And I say, okay, if you're not cheating, what's the probability that you win 70% of your games out of 100 games? Okay, that probability turned out to be extremely low. So we said, we've got enough evidence to reject this notion that you're not cheating. Is it possible that I got really lucky? Yeah, it's possible. It is technically possible that I was one of the lucky 3 in a million, but more likely that I'm not. Okay. And on the other hand, when we came back to the casino, I won 60% out of 30 30 games. So what's the probability of winning 60% out of 30 games if the null hypothesis were true, meaning if you're not cheating? And that probability turned out to be 8%. Okay, so that was pretty large, so we can't say, we can't reject the null hypothesis. Alright, so, okay, so that's the overview. We'll get into all of the steps, but are there questions on anything so far? Yeah, Rebecca.
So enough evidence you can reject the null, not
Yes.
enough evidence is the alternative.
Returning the hypothesis.
Okay, so when you reject the null, that means you automatically accept the alternative. Okay. And if you don't have enough evidence, it just means you don't reject the null, and that's it. Okay, you don't reject the null, or you don't accept the alternative. Okay, we'll get into okay, so we're going to set up hypotheses. So step 1, create hypothesis. And so you have a null hypothesis. Which we call H0 or H naught. It was all for naught. Okay? And the alternative hypothesis HA. Now, when we did our null hypothesis for this thing, we wrote it out in English, but for this chapter, our null hypothesis is all about proportions. And the next chapter, it's going to be about means, but for this chapter, it's going to always be about proportions. And so we would write P, and we set it equal to some number. Okay, so I'm going to just make up a number, maybe 48. Okay, so I just made up the 48. This is just an example. Okay, so the null hypothesis. Technically it's a hypothesis test for one proportion. Okay. We'll see hypothesis tests for two proportions and things like that. So we've got P is equal to 0.48, and then the alternative is P does not equal, or P is greater than, or something. So this is just an example. Okay. So of course this number won't always be 48.48. It might be something else. So things to note: the null hypothesis always has an equal sign in it. And then the alternative will have either not equal to, greater than, or less than. And we'll talk about the difference between all of these. So you create the hypothesis. Then there's a few steps, okay? One is you pick an alpha, And alpha is also known as the significance level. And this is the point where we decide if a probability is large or small. So most common choice for alpha is 5%. Okay, but equally valid is alpha 1%, alpha 10%, or anything else. Truly. Anything else is equally valid.
Thank you.
We're going to find the test statistic and p-value. These are terms that you probably don't know anything about, but we've seen it, okay? So basically, it's just find the probability of the p-value is the probability of observing your data or something more extreme if the null hypothesis is true, okay? It's a long definition, but we're going to just repeat it over and over and over until it gets drilled into your head. And then maybe I'll just have you guys memorize it. And sometimes when you memorize something, it doesn't make sense at first, but then eventually it clicks, right? I don't know. Like, well, okay, I'll write it up on the board. But like, the Pledge of Allegiance. Do you guys have to say that in elementary school? Okay. Yeah, it's like in first grade, you have no idea what the words you're saying. And then maybe like somewhere like 5th or 6th grade, it clicks, and you're like, oh, I'm talking about the flag. You know? The flag in the country, okay? Yeah, and then I know I've got international students here, but I don't, you know, maybe do they, and so my international students, do they do anything similar? No, nothing? Do you even know what a Pledge of Allegiance looks like? No. You do now? You like, you stand here and you're like, there's a flag, you're like, I pledge allegiance to the flag. It's rather bizarre if you think about it. But I remember coming to college and thinking, don't we say the Pledge of Allegiance? Because we did it every day all the way through my high school.
Yeah, I think
in high school
everywhere.
too. Huh?
I think everywhere, right? You did?
I know other people, they say they
I
didn't do it in high
refused,
school.
but we had
You
to.
refused? A rebel, yeah. Alright, so find the test statistic and p-value. Okay, so the p-value, this is the definition that you're going to have to memorize, okay? Is the probability of observing your data, so the probability of the data, not the hypotheses or anything else, of observing your data or something more extreme if the null hypothesis is true. Or were true, okay, subjunctive case is were. If it were true, it is true. Yeah, it should be were. If it were true. big, yeah, anything in between, I mean, even higher if you can justify it, okay? Okay, I guess nothing over 40%, but yeah, I mean, you could go higher, but you gotta justify it. Generally, between 1 and 10% people will accept. If you go outside, or even maybe 0 to 10% people accept, but then, I should say 0. Yeah, 1 to 10% people accept without question. If you pick more extreme numbers, then you better have a good reason. Okay, so anyway, this is the p-value. Alright, the p-value is the probability of observing your data or something more extreme if the null hypothesis were true. Okay, I've already erased it, but that was like, what is the probability that someone who plays 100 games wins 70% of his games or more if the null hypothesis were true, if the probability of winning is actually 0.474. Or what's the probability someone wins 60% of the games out of 30 games if the null hypothesis were true. And so this part involves this statistics calculation, okay? And then finally, the last step is make your conclusion based on your p-value and alpha.
The calculation is step 4.
Well, step 3 is probably the biggest one with all of the calculations, okay? This is part of calculations today. Okay, and so the last part, make your conclusion based on the p-value and alpha.
Basically compare it, right?
Yeah, you compare the two.
And then you see
If your p-value is smaller than alpha, you're going to reject the null and accept the alternative. If the p-value is bigger than alpha, you do not reject the null. Do not accept the alternative.
Can you write that down?
Yeah, I'll write that down. I'm just
That's
trying to
very
look
good,
for
yeah.
space. So I'm going to erase this stuff here. So, you know, we got p-value and we have p. Don't mix those two up. They're different. Okay, so if p-value, so if the probability of observing your data is less than alpha, okay, the probability of observing your data. So if it's the 3 in a million case, if the probability that somebody wins 70 out of 100 games is 3 in a million, you reject the null hypothesis, which is you reject the idea that he's not cheating, and you say we have evidence that someone is cheating. Okay, so if the p-value is less than alpha, you reject H0, the null hypothesis. Okay, and then you accept the alternative. So these two things happen at once. When you reject the null, it means you've accepted the
that means
alternative.
there's enough evidence to show that
Yeah.
there has been
And
cheating.
then you say
This means
you have enough evidence to reject 0. You have enough evidence. These are all saying the same thing, just to let you know. So that's if your p-value is less than alpha. And on the other hand, p-value is bigger than alpha, okay, do not reject okay, do not accept. You do not have enough evidence. So notice, I never say accept the null, and I never talk about rejecting the alternative. Okay? Accept only goes with the alternative, and the null only goes with reject. Okay? So I never talk about accepting the null hypothesis, and I never talk about rejecting the alternative. Okay? It's either I reject the null, or I don't reject the null. I accept the alternative, or I do not accept the alternative. Okay? Why is that? Yeah. Yeah, the null is the default. The null is the default. So if you think of a criminal case, right? We presume the defendant innocent until proven guilty. Okay? In our justice system, we don't try to prove that the defendant is innocent. Okay? It's the prosecution's job to prove that the defendant is guilty. And so if you don't have enough evidence, then you let the defendant go. It doesn't prove that the defendant is innocent. It just means you don't have enough evidence to say this person is guilty. Yeah?
Right, so you either prove they're guilty or you can't prove it.
Yeah, you either prove that they're guilty or you can't prove that they're guilty, okay? And if you can't prove that someone is guilty, it doesn't mean that that person's innocent. It just means you can't prove that they're guilty, okay? And so, so anyway, that's how we have the hypothesis test set up, okay? And, so yeah, we just default to the null. Okay? All right. Well, let's take a little break there, and then we'll come back and we'll do a few examples, and then we've got some more stuff to cover.
Jen.